we'll start with isotopes, which is what decay is focused on. So isotopes, which is any particle that has a different number of neutrons, okay? So it has the same number of protons and electrons, but a different number of neutrons. Reviewing our charges, we know a proton, he's positive. An electron is negative. You just kind of need to know that one. There's not really a thing for that one. And a neutron is neutral, so 0. She'll try and like trip you up. Isotopes are always neutral, okay? They have the same number of protons and electrons. 1, -1, pretend that's -1. Okay, so +1 plus -1 equals 0. Okay, so protons, electrons will always be neutral. Okay, they'll always be the same number. So like you'll have like 1,000,000 protons, like 500 because I can't write 1,000,000, and like the same number of electrons. 500 minus 500 is 0. Okay, always 0. If we remember from the beginning of the year, I think, I act like I'm in this class, I'm not. We have, our mass is always determined by what's in the nucleus. So like we could have protons and neutrons and protons and neutrons and protons and neutrons, because protons and neutrons are in the nucleus, right? Just draw like a little atom. All right, we look in the nucleus, what do we see? We see our protons and our neutrons. So that's how we determine the mass, okay? So, I believe it's A, X, Y. That could be wrong. As like your little notation, so you have like your mass number, you have your atomic number, you have your, the name of whatever you're looking at. So, for example, we have carbon 12, which is just what we call it. I don't know why we call it that. Actually, I do know why. So carbon 12, it has 6 protons. 4, 5, 6, plus. 6 protons and 6 neutrons because there's 12. Okay, 1, 2, 3, 4, 5, 6. That's carbon 12. And then, because it's a neutral atom, it also has 6 electrons on the outside. That's carbon 12. All right, we can confirm this. I'm not flipping it upside down this time. Mass number of carbon is roughly 12. Its atomic number is 6, okay? So, 6 protons plus 6 neutrons equals 12, okay? Boom, got it. All right, so alpha decay is shaped like an A, and an alpha particle, he's the biggest boy in the pack. He's an alpha, all right? So he's pretty big, relatively big. I'm gonna color in the neutrons black for right now, and then I'll just do the protons like that. Okay, so an alpha particle is made up of 2 protons and 2 neutrons, okay? So our mass number is gonna be 2 protons plus 2 neutrons, which is 4. And then our atomic number, again, is just how many protons we have. So we're gonna do 2. And then because we're working with an alpha particle, we're gonna put an A there for alpha. All right. So I'm gonna do carbon the whole way through here, just for, so I don't make my brain hurt, because I know how to do 12 minus 4, and that's about it. Okay. So we have carbon 12, it's gonna go through alpha decay, right? So he's gonna spit off an alpha particle in order to become more stable. And so he loses 2 protons and a mass of like 4. Okay, I can't really explain that any better. So 12 minus 4 is 8, right? And 6 minus 2 is 4. Okay, so whatever new particle we have here has 4 protons. So we look on our periodic table. Boom, it's beryllium. Beryllium. Right, so carbon spit off an alpha particle, turned into beryllium. She also has you do these like fill in the blank ones. So I'll do the same problem. Because I'm lazy. And she'll be like, what happened here? And it'll be like alpha, beta, gamma, okay? So what I do is I start with the top here, so we have 12 and 8. So we start with 12, and that turns into something plus 8. Algebra jump scare, okay? If you do algebra, right, you know how to do that. 12 minus 8, x will equal 4. So we end up with 4. And then same thing here. I'm not going to write it out because you don't need to. 6 minus 4 is 2. And then we end up with an alpha particle because 4 and 2 means alpha, okay? For our beta particle, a beta particle is just an electron. It's just, I don't know why we call it a beta particle. I've never used that outside of Mrs. Kin's class, so you can tell her that. A beta particle is an electron, okay? An electron has 0 mass, basically. It's like 9 times 10 to the negative 21st or something. It's like really, 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 really small, okay? And we know that an electron has a charge of -1, okay? So a beta particle is an electron which has 0 mass and a charge of -1. Beta, okay? So for this one, we'll do carbon 12. Goes through beta decay, which is this plus something, okay? It loses 0 mass, we can see that. So we end up with 12 on top. And when it splits off, it ends up with this little negative piece, right? Okay, so this is kind of like reverse of what we just did. So again, I'll just whip out the algebra. Okay, it's just 6 protons equal a beta particle plus something. We solve for this, so we add 1, we end up with 7 equals x, so we end up with 7 on the bottom. Because, again, we can think about this as if we add 7 and -1, we end up with 6, okay? We look for the atom that has 7 protons because 7 is our identity number, so to speak, our atomic number. We end up with nitrogen. That's an M. Nitrogen. Okay. And then the fill in the blank one, same thing. Carbon. Oh no, we don't know. And nitrogen. So we end up with 6. There's 0 here. Okay, so there's nothing happening there. Okay. We have 6 equals x plus 7. Subtract the 7 to get x by itself. -1. -1. And we're like, okay, we know that's an electron because it has a -1 charge, and an electron is a beta particle, so therefore it's beta decay. Again, if you want to remember that the electron's a beta particle, he's smaller than the alpha. He's smaller, so we have like alpha big, electron, small. Okay. I promise I'm mentally fine. And then we have gamma, which I still, to this day, I cannot draw a gamma sign. It's an upside down Y. Why? I don't know. And a gamma radiation is just waves, okay? It's just waves. So waves, they're not made up of protons, electrons, or neutrons, so it's just 0. And because of that, it's 0 on the top too. It's nothing. It's basically nothing. I don't know why she makes you do these. It's nothing, okay? It's just nothing. Beta, or not beta, gamma, nothing. All right, so we have our carbon-12, gamma radiation, same on both sides. That's also still a plus sign. Boom, okay. So if it's the same on both sides, it's gamma. The way I remember this is this like gamma symbol. I always write it like that, but like it's technically like that or something. It just kind of looks like a wave to me, so I just think waves, which are made of nothing. Okay. And then we also have, I didn't move the paper. We also have like what they get stopped by, which I know she quizzes you on. So we have the alpha particle, which is the leader of the pack. He's the biggest. I like to think of him as the fat kid playing Red Rover. Like Red Rover, come over. Red Rover, let alpha particle come over. He's too fat to get through the barrier of like paper. Okay, he's just too big. He's too heavy, he bounces right off. He can also not run very far, so like air will stop him. Like he won't get very far. He'll just kind of like, I don't know. He's gone. He's fat, he can't get anywhere. Okay, perfect, remember that. All right, beta particle, it's an electron. If you remember, in the beginning of the year, you learned like the history or whatever, and they found out that electrons existed, I believe, by kind of shining them against tinfoil, and they left little like imprints. And that's how I remember it, is that like the electron just kind of like shows up on tinfoil, and therefore it's stopped by it. I believe it's like 5 unit, insert unit here. I think it's like centimeters. It might be millimeters, it might be inches, I don't know. It's probably not inches. But electron or beta particle, they're the same thing. Be who you always. I love Hosier. That's a good song. Wasteland, baby. Yep. Electron bounce off tinfoil. Pretend that is tin. All right. And then for the last one, again, these are nothing. They can basically phase through anything. I'm trying to think of like a superhero that can phase through anything, but I'm forgetting at the moment. So just forgive me. So they can go through paper, just fine. They can go through tinfoil, just fine. Something really, really big has to stop them, like a concrete block in this example. So concrete stops these like amazing waves from going any further, okay? So alpha gets stopped by paper, beta gets stopped by tin, gamma gets stopped by concrete, okay? Alpha is 4-2 because it's the biggest. Beta is 0, -1 because it's an electron. It has no mass and a -1 charge. And gamma, which is shaped like a wave, is nothing, okay? Ta-da! Let me know if you have any more questions.